Questions in modern medicine. It's a real mystery that doctors and patients face all the time. Why does cancer sometimes come back, even when it looks like a treatment has completely wiped it out? Let's get into it. It's just a devastating scenario. A patient goes through treatment, they respond well, the scans look clear, and everyone breathes a sigh of relief. And then, a few months later, the cancer is back. So what's going on? Well, a team of researchers in Australia started using AI to try and crack this very puzzle. So the treatment we're talking about here is immunotherapy. And it's an amazing idea. It basically trains your own immune system to hunt down and destroy cancer cells. In this study, the researchers were focused on non-small cell lung carcinoma, which, by the way, is the most common type of lung cancer out there.
Now, for all its power, immunotherapy has a catch. It only seems to work for about 20 to 30% of patients. For everyone else, something's just not clicking. And figuring out what that something is, well, that's absolutely crucial.
And here is the heart of the mystery. For some of those patients who do respond well at first, about 6 to 8 months down the line, the cancer pops back up. But get this, it grows back in the exact same spots as before. It's not a new tumor somewhere else, so something special must be happening in those specific locations, right?
To figure this out, researchers over at the University of Queensland tried something new. They decided to use AI and machine learning to go undercover, to basically spy on the individual cells that make up the tumor.
And I love this quote because it really gets to the heart of what they did. Instead of just looking at the whole tumor from a distance, they zoomed all the way in. They were looking at the personal lives of these cells, how they were behaving and interacting with each other.
So, what was the first thing these spies looked for? Sugar. Yep, simple glucose. It's a well-known fact that cancer cells are total sugar fiends. They just gobble it up to fuel their crazy growth. So the researchers used their AI to map out exactly which cells were eating the most.
And that search for sugar led to a huge breakthrough. The AI found something really interesting. It wasn't just single cells being greedy. It was entire neighborhoods inside the tumor that were basically hotspots of activity.
This comparison here explains it perfectly. In these greedy neighborhoods, the cancer cells were hoarding everything. I mean, they were sucking up all the sugar and all the oxygen, creating this little resource-depleted bubble around themselves.
And here's the punchline. The immunotherapy wasn't failing across the board. No, it was being actively sabotaged in these hotspots. The cancer cells were literally starving the patient's immune cells, the very T cells that the therapy was trying to activate. An immune cell can't fight if it has no fuel. So in those little pockets, the cancer survived.
Okay, so once you know how the enemy is defending itself, you can come up with a much smarter battle plan. And that's exactly what these researchers did.
They're proposing this really elegant three-pronged attack. So you still hit the cancer with chemo to weaken it, you still use immunotherapy to rally the immune system, but you add a third weapon, something called a metabolic inhibitor. This new drug's whole job is to stop those greedy cancer cells from hoarding resources, which finally gives the immune cells a fair fight.
What's so exciting is that this discovery isn't just about lung cancer. This is a massive step forward in how we think about treating diseases in general.
This is the ultimate goal. This is true precision medicine. Just imagine a future where doctors don't just see cancer, but they see a detailed map of your unique tumor, understanding the personality of every little neighborhood inside it. And with that map, they can mix a treatment cocktail that's perfectly tailored for you.
So, what's the big takeaway here? It seems like to truly beat cancer, we have to start thinking of it less like a single disease and more like a complex living ecosystem. And maybe, just maybe, understanding a cancer's unique personality is the real key to figuring out how to defeat it for good.